Yes, hello everyone. Welcome to your physics classroom. I am Adetunji, your physics tutor. To our returning viewers, welcome back to your physics classroom. To our new viewers, welcome to physics classroom. Please do well to press your like button, your subscribe button, your notification bell. Hit your like and share our program. Please comment in the comment box as we continue with our physics practical. As we all know that we are in the season of NECO 2025. We have done a lot of videos. This is another video on physics practical methods, question 1, based on equilibrium, and we can see the diagram very well vividly. Now we have a diagram here telling us something, and what is telling us that we have our object N. We have a mass N, which is 100 grams, but it will be unknown to the candidate. They said we should be placed 10 centimeters away from the center of gravity, like you can see it on the screen on my board here. Now, like I told you, the first thing we need to do anytime you are doing equilibrium practical, you determine the center of gravity of your meter rule. Like I told us in the preamble of this practical in our previous video, when we were releasing video on the specimen, I told you whenever you are carrying out practical on equilibrium, the first thing you must do is to determine the center of gravity. That is what I want to do right now. I have told you not all meter rule center of gravity is 50 because it depends on the material. That's why you need to know your center of gravity. That's what I want to do right now. I believe you can see I'm trying to balance. Wherever it is balanced is my center of gravity. Okay, it's not balanced, it's falling. I think it's balanced now. Now, before you talk about center of gravity or your meter rule to be balanced, ensure that the environment you are is free from air. Ensure you don't want fan, anything that can blow it away, make sure you are away from it. And luckily for me, my meter rule is balanced at 50. Yes, it's balanced at 50. So I give myself congratulations for using original ruler again. I don't need to waste time, but I just want you to see that it's balanced as 50. Now let's move forward. Now, like I've determined mine, and I got 50 centimeter as my CG. My CG, that's my center of gravity. I'll be writing here because I want to do the practical with us. That is 50 centimeter. So definitely now I want to start the practical without wasting time. In the question we are told that we were told using a piece of adhesive that it has been attached 10 meters away from the center of gravity. Suspend a known mass 50 grams using a thread and hang it on the other side of the center of gravity so that the meter will balance horizontally. That's what we want to do right now, which my camera will show you right away. Now, the 100 grams that is unknown to candidates, which is label N, is already here, like you can see. And likewise, my center of gravity is 50. The thing must not shift. That 50 must be fixed. Now, my adjustment is now on this side. Any mass I'm putting, I'll be adjusting it. Now, I'm holding my mass 50. I want to balance. My meter rule according to the statement. I want to balance. When you are balancing, you ensure that the thing is not touching the table, and likewise your center of gravity. I maintain my center of gravity and I want to balance, which I believe you can also see. I will not stay long on this so that the video will not be longer, but at least I need to show us one or two for us to know the way it is being done. So I want to try to balance the first one, and we see and we record values there, and we move forward. And when you are balancing, like I told you, please you make sure that your environment is free from air. You don't want the fan. The fan is no wind, nothing is blowing, so that your meter rule will be able to balance on time. I think my own is balanced, and is balanced at 70. So What I mean by balanced at 70 is that the point at which this meter rule, this thing is on the meter rule is 70. I will now need to know the distance between that 70 and my center of gravity. That is 70 minus 50 will give me 20. So the distance, my distance is 20. Maybe I should explain that statement again so that you will not feel confused. When I was adjusting this thing, the thing got balanced at 70. That is the position where it is. Now, did I say what the distance, which is measured by D1, the distance between that point and the center of gravity? 70 minus 50, that is 20. That is how this one, that's how I have 20 here. Now, let me go to when my M is now 60. I will still draw my table comprehensively, but to avoid wasting of time and to sit very properly with the experiment, that's the reason why I don't want us to be moving much. But comprehensively after the experiment, I will bring out the comprehensive values. Now I want to increase it to 60. Now this 50 plus 10 equals to 60. So I want to add 10 to it and let's see what will happen. I want to add 10 to it and let's see what it will happen. You can see the thing is about a little bit falling. A little bit falling, so it's requesting for adjustment. You know, the thing is falling toward this side, so I need to adjust toward this side. What you need to know about this experiment is it's following the principle of moment. When you see that you apply a load and the meter rule is falling to that side, you need to adjust toward the center. That's why I call the center of gravity, to balance it. So I want to move it closer a little bit to the center of gravity to see how it can fight for its balancing. That's what I'm still doing. It may be rolling, but that's why I need to calm down to make sure. Still going to that side now. Adjust. I don't want to take much of our time in this video. Now it's falling. I need to pull it back. Like I said, I won't waste our time. It's just the first 2 experiments I will carry out, and the rest I will leave it. I think here is balanced. So I'm adjusting, working towards the balancing. Once it's showing the sign of balancing, I will take my reading straight up. As long as once it's not touching the table, that's when it's balanced. Remember the environment we have. At least there's no way you still have a little breeze inside, except you are doing it where there's no air at all in the space. Yes, this one is balanced now at 67. Now, 67 minus 50. 67 minus 50. 67 minus 50 gives us 17 centimeter. 17 centimeter. So I would now, let me also do the rest, but in the video it will be a little bit, because so that the video will not be longer, so the comprehensive report will be given at the end of the whole experiment. Yes, now we have our comprehensive result after the whole experiment. So when we are at 50, when we did it, we got 70 as the point, and the distance from that point and center of gravity is 20, 67, 17, 64.3, we have 14.3, 62.5, we have 12.5, 61.0, we have 11.10. So with this now we have fulfilled procedure 1, procedure 2, procedure 3, procedure 4. Procedure 4. Now the same we should repeat, which we have also done. That procedure 5 has been done. Tabulate your reading. That's procedure 6 we have done. Procedure 7 said that we should plot the graph of mass M in what? Plot the graph of mass M in the vertical axis, that is, well, now this time around I want to talk about the issue of graph. We are done with the table. Now graph. You know, when you talk about graph, we need to take our time very well to draw a graph, to plot our graph rightly, because of the value of the mark it carries. The first thing we need to know is that when you talk about graph, there must be title. I know somebody will ask me, where are we going to get the title of the graph? The title of the graph will always be in your statement, in the question. Where they say plots, they have already given you the title. That is the graph of mass mg against d1. That is the title. The title of the graph, if you like, you can say the graph of, you can say the graph of mass, or M, anyhow you call it, mass in gram, that is M. Maybe I should use M because M is always on the table. M G against our D1 in centimeter. D1 in centimeter. And from there again, we'll talk about our scale. We'll talk about our scale. Now, before we talk about the scale, you know, our graph, we are expecting a graph to be something like this: mass on the vertical axis, and the distance, the D1, on the horizontal axis. Check the values. What's the lowest value for mass? We have 50, and the highest is 90. Based on your graph, I think I may be good with 2 centimeter to represent 10 units. 2 centimeter to represent 10 units. That is, I will say, on MG axis, 2 centimeter to represent 10 grams. You know, I was supposed to say 10 units, but my unit I mistaken. My unit is gram, so 10 gram. So 10, 20, 30, 40. Now start that 50 that I need, now start picking up. And the highest value will stop at 100, and the 90 is already inside the range. So I will have my 0. I will still talk about, we'll use the original graph. I'm just making a sketch right now. Same thing goes to about our distance. You check your distance very well. The lowest distance I have here is 11.10, and the highest is 20. With my level of graph, what about if I go by 2 centimeter to represent 2 units? I can have something. I'll also show us on our graph that if I use, I can say on 1 centimeter axis, 2 centimeter to represent 2 centimeter. Okay, let me say 2 centimeter to represent what you can see visible in your graph is what I'm thinking of. Let's say 2 centimeter to represent 2 units. And this was my unit, 2 centimeter as well. So 2 centimeter to represent 2 centimeter. And at the end of the day, you plot your graph. If you check, let's check the gradations to see how the graph will go. When the mass is increasing, the distance is falling. So definitely we'll be having a graph. As the mass increases like this one is decreasing. So definitely we'll be having a graph of inverse. We'll be having a graph that will fall. We have a graph that will fall. Take an instance, if I say maybe at 50, you have 20, 60, at least it will be falling. You can see as the mass is increasing, so I will have a graph that will fall like this, and at the end of the day, I will find the slope. And after that, my slope will be talking about the distance. If you like, and do your own your other side. Or want to achieve that slope is equals to change in the vertical axis Like I said, there will be a comprehensive video on graph. That is, it will only be the table and the graph you are going to plot. So change in mass, that is the vertical axis, over change in horizontal axis, which is D1, change in D1 centimeter. So when you do all these things, I'll be having maybe M2 minus M1, you put G, the unit, over D2 minus D. If I won't use D2 minus D1 here because you know we are working on D1, I can only say maybe D1 2 minus D1 1. Okay, D1 2 minus D1 1, I think that one is okay, centimeter. And from there, whatever the answer we get, it will be gram per cl. That is gram per cl. So that is talking about the graph for this practical equilibrium. We have interpreted, we have solved all the questions given to us, all the instructions, we have followed all the instructions, and we have put everything in place. They now ask us to state 2 precautions taken to ensure accurate results. When we were doing the experiment, what are those things we faced and what are those things we avoided? You remember when I was doing it, I said something about air, that you ensure that you are carrying out the practical where there is no or little breeze, little wind, to avoid imbalancing of your meter rule. The major precaution as well, since I'm using meter rule, I avoided error due to parallax when taking readings. When taking my readings on the meter rule, you can see as I was taking my measurement, I ensure I'm picking out the right values. I also ensure that my meter rule is fixed on the center of gravity. I ensure that one is fixed on the center of gravity, and so I've measured like 3 to 4. So all those things are the precautions that we state. So this is how we finish another particular aspect of physics practical NECO 2025 mechanics equilibrium. We are still coming with another experiment in your next video. So please do well to like, share, and put comment in the comment box. I'll be waiting to see you in the next video. Before I say bye, for our biology and mathematics, please do well to visit our second channel for our mathematics and biology. For biology practical, biology theory, mathematics as well, please visit our second channel. You will see it in your description below. You will see it in the description below, our second link. That is where you see the practicals on biology, agri, mathematics classroom as well. Thanks for being there. Bye for now.